Hello everyone, and welcome to another Mini Sky Tonight. So one of the topics I wanted to discuss with you folks is the motions of the sky. Many people often get confused of how the sky moves with respect to space because they have a limited view based upon where they're located, and they look up at the sky and they think, oh, because of their limited view, this is how things work. When in actuality, when you get to step out into space, you see something completely different. So I wanted to provide an opportunity for you folks to be able to step out into space and to take a look at what's going on in space versus what we see in the day, to kind of help better understand how our sky moves and what we're actually seeing. And the two celestial bodies I wanted to cover today is the sun and the moon and how they move with respect to our planet. So let's dive deep first into our sun. So let's talk about day and night cycle. The sun rises in the east and sets in the west. We get to have a day and a night, and that's how it works, right? Well, in actuality, the sun is not moving at all. It may look like it's moving and trekking across the sky, when in actuality, when you step out into space, it's our Earth that's rotating that gives us the perception of the sun rising. So as you can see in this diagram right here, as the Earth rotates, and the two little lines right there is our field of view, we get to see from one horizon something rise, and then from the other horizon something set. So it basically limits our view of what we can see. So think of being on the old-fashioned merry-go-round, where you're sitting there and you're turning around and you get to see different perspectives of which way you're pointing towards. And that's the same thing with day and night. The sun is pretty much stationary, but it's our rotation, us turning on our axis, that allows us to see the sun in different perspectives. Now, we get to see the sun and we get to see all the stars and everything, but our field of view is limited. As you can see in this diagram, it's that little wedge that is what we can see from horizon to horizon. But we also have the problem too of our atmosphere. And why might you think that? Well, it has to do with a concept known as Rayleigh scattering. What's going on with Rayleigh scattering is that the light from the sun hits our atmosphere. And in our atmosphere, we have water droplets. And those water droplets act like prisms or rainbow catchers in the sky. You know, like those little glass things that you get from the store, and you can put them in your window and you get to see all these beautiful rainbows displayed across your room. Well, that's what's going on in our atmosphere. Light from the sun hits these water molecules and it spreads the light out into its many colors. But blue light easily reflects in water. So all the colors eventually come down to Earth, but blue light stays up in the sky for a longer period of time because it bounces around from water molecule to water molecule really easily before it does eventually come down to Earth. Now, it doesn't take that long because we're talking about light here, which travels at the speed of light. So it's really fast, but from our perspective, it takes a long time. So that limits our view of the sky. So during the day, we can't see stars or constellations, but at night we can. So how does a typical day look? Many people say it rises in the east and sets in the west. Partially true, but it doesn't always act that way because it depends upon the time of year. So let's take a look at how the sun rises and sets at the different times of the year. So let's talk about these 4 crucial points. The 4 crucial points I'm talking about is the autumnal equinox, the summer solstice, the vernal equinox, and the winter solstice. Not in any particular order. So you have the 2 solstices and 2 equinoxes. At these particular 4 points, the sun acts differently. So let's take a look at how the sun behaves during an equinox. Fortunately, vernal and autumnal, or spring and fall equinox, act pretty much the same. The sun rises in the east and sets in the west, like what everybody expects. In fact, the term equinox means equal night. You get 12 hours a day, 12 hours a night. or relatively close. So what I did with this video is basically zoomed us out in this little window over here towards the right of what it looks like from the perspective of space. Now, the program I used to create this video is called Digistar 6. It's the program that we use in our planetarium to be able to put it up onto the dome. Now, this is a program you can't get yourselves, but hopefully in 2021, we will be able to open up our doors again and have you folks come to be able to see our planetarium shows. In fact, we would love to have you folks come back. We have been missing you tremendously, and we look forward to being able to open up our doors in a safe manner. So keep an ear out for the news and/or keep an eye on our Facebook page to hopefully learn some more information of whether or not we're going to open. Nonetheless, let's go back to the video and let's take a look at what the sky does during the spring equinox, a typical day on an equinox. So as the sun progresses, it sets in the west. And as you can see here on the Earth, our Earth is rotating to where now we're facing the nighttime side, and the Earth rotates back to where we're facing the sun. And notice where the position of the sun is right there. It's kind of close to the equator. So we get the sun covering almost all of the Earth equally. So we get equal day, equal night. So everything is equal during the equinoxes close to. So it rises in the east and sets in the west, what we think of as a typical day. But something changes as the months progress. So let's progress further into the winter solstice, the winter time. So what's going on during the winter solstice? As you'll notice, by just taking an initial look here in the video, the sun is much lower in the sky. In fact, the ancient people were terrified of this time. They didn't understand what's going on. They just noticed that the sun got lower in the sky and they received less heat and light from the sun. And they thought maybe the sun is dying. So they would often hold these ceremonies to encourage the sun to battle the powers of death and darkness. And the sun would continue on its upward course again. Now, to the ancient people, this was a big deal. They basically felt like they were influencing the cosmos, when in actuality, it has to deal with something else, which we'll get into a little bit later. But let's take a look at what a day looks like during the wintertime. Notice by looking over here in the little window that I've created from a top-down view of Earth, notice that portions of the Earth are really dark. At the North Pole, the sun never rises during the wintertime. You literally have 24 hours of total darkness, no sunlight whatsoever. It's crazy. That's why astronomers and scientists that are near the poles have to put themselves on a rigorous schedule in order to be able to not have sleep deprivation, because there's no day or night cycle that they can depend on to help keep with their circadian rhythm. So in this particular case, since the sun's light is not as direct during the winter time because the sun is lower in the sky, there's portions of the Earth that receive no light during this time. And as you can see here in the window, the sun is really low. It used to be here close to the equator, but now the sun is really low down here. So let's take a look at what a day is during this winter solstice. Now, as you can notice, the sun sets in the southwest, and we have a very long period of time for the night. And then it starts to rise in the southeast. In fact, the ancient people sometimes said the sun rises late and goes to bed early during this time. So we have a very short day, but a long period for the night. So what happens as we progress further? Well, the sun starts to rise up until it reaches its highest point, known as the summer solstice. So then notice the sun is really high in the sky, and it sets now in the northwest, and we have a shorter period of the night, and it now rises in the northeast. And and it makes a bigger arc in the sky. And it's really high in the sky now. So we're getting much more direct sunlight directly facing down on us. And as you can see, the sun is now here pretty close to Mexico, when the sun used to be all the way down here during the wintertime and somewhere here in the equator during the equinoxes. So the sun looks like it's wobbling in the sky during these different times. So what's causing this wobble? This wobble is sometimes playfully known as the seasons. So what creates our seasons? Well, many people believe that, oh, our seasons are created because the Earth is closer to the sun during one point of the year and it's further away from the sun during another point in the year. Actually, that's not true. Our sun is tilted 23.5 degrees. And it's that 23.5 degree tilt that gives us our seasons. Now, the Earth is tilted 23.5 degrees to where the pole is pointed towards the North Star. And it always stays there, and it's always pointed towards the North Star. So the Earth goes around like this. In fact, allow me to show you a video of what's going on with our seasons. So here we are during the winter time, and as the sun projects its rays, we're getting less direct light because, again, it's pointed towards the North Pole. The North Pole is pointed towards the North Star, so we're getting less direct rays during the winter time. But as we go around the sun, and I love to add the rotation of the Earth to show you that we're experiencing days and days and days, it eventually comes down towards the other side of the sun to where we're facing summer. Now again, the pole is still facing the North Star. Since it is, it looks like the sun, or the Earth is tilted towards the sun, and we're getting direct rays from the sun. And spring and autumn, which lie in between, is where we get the sun covering up the majority of the Earth. And that's where we get our equinoxes. And then here we are back at winter. Now, to break the myth that we are closer to the sun during the summertime, we're 0.98 AU during the wintertime and 1.02 AU away from the sun during the summertime. We are farther away from the sun during our summer. So that blows that myth out completely. What causes our seasons and the rising and setting of the sun in different locations has to deal with this natural tilt, as we like to sometimes call it, the wobble of the sun. Now, to kind of take a unique perspective from this point of view, I sometimes get the constant questions of, hey, I want to see Orion. Where's Orion? It's not up yet. Well, why isn't it up? I want to see it. Well, it has to depend upon where we are located in our orbit and whether or not we can see it. As I mentioned earlier, we are limited in our view by not only this angle, but during the day we can't see constellations. So one unique video I created was to demonstrate some of the different constellations. So since we can't see constellations during the day because of Rayleigh scattering, because it's a blue sky, we can only see constellations at night, which means we can only see constellations that are facing away from the sun. So as you can see here before I start the video, our Earth is still tilted 23.5 degrees, but on the nighttime side, we're able to see constellations, but on the daytime side, we can't. So we're only able to see constellations that are facing away from the sun. In the case of December, the constellation I have displayed right there is the constellation Taurus. So during the wintertime, at night, we see the constellation Taurus, but we cannot see the constellation Sagittarius, which is close to the sun at the time. And as we go around looking at the spring, we can't see the constellation Pegasus, but we can see constellations that are in the spring. During the summertime, we see the constellation Sagittarius, but we cannot see Taurus now. And in the fall, we're able to see the constellation Pegasus, but we can't see constellations in the spring. So given these different perspectives of where we are in our orbit around the sun, we see different constellations at the different times of the year. So that's why many people were like, hey, I want to see my zodiacal sign. Why can't I see it? Well, it might be because it's up during the day. All right, now that we've taken a look at our sun, let's take a look at our moon and how it orbits around our Earth. So one orbit around the Earth is roughly 29.5 days, or 1 month. The ancient word for month was month because we get 30 days for the cycle of the moon, so therefore our days for a month is 30 days. Now, some people may ask, well, what about this 27.3 days? Well, there's 2 times where we've measured the orbit of the moon. One is with respect to the stars, and the other one is with respect to the sun. Now, the Earth is going around the sun. And since the moon is going around the Earth, it has to do a little bit of catch up to get back to where the sun is in alignment again. So to go back from like new moon all the way back around to new moon, because the Earth has moved, takes a little bit longer. Whereas in the stars, since they're close to stationary, go back around and go back to the same position of the stars. Whereas in the moon, where the sun, as we saw earlier with the different positions of our sun, the sun looks like it's moving, so therefore the moon has to catch up just a tiny little bit. So it's 27 days with respect to the stars and 29 days with respect to the sun. But that's how we measured our months, is with respect to the sun. Now, there is no dark side of the moon. Many people think, oh, the reason being why we see different phases of the moon is because there's a physical dark side of the moon and it's rotating towards the Earth. That is actually not true. The moon is always facing the same side of the moon is always facing the Earth. It's what is known as tidally locked. So it rotates at the same rate it goes around the Earth. So we always see one side of the moon at all times. So there's no physical dark side of the moon that's rotating towards us. It has to deal with the shadow, depending upon where it's located in its orbit. So here's kind of, as you can see, a picture right here of the near side and far side. There's no such thing as dark side of the moon. Sorry, Pink Floyd fans, but that's how it is. We call it the near side or the far side of the moon. In fact, the far side of the moon is much lighter than the near side of the moon. So given where the moon is in its orbit and with respect to the sun, we get to see the different phases. A good way to test this is by basically putting a ball on a stick and holding it up close to a lamp, and then letting the moon, your moon, go in orbit around your head, and then you'll get to see the different phases. In fact, allow me to show you kind of like a top-down view of the moon, and in this little window, it shows you the phase that you can see given its orbit and position. So here's this little dot is the moon. Yes, it's tiny because the moon is 1/4 the size of the Earth. It's like comparing a baseball to a basketball, so it's tiny. Now, the part of the moon that's facing towards the sun is always lit, but depending upon our position in our orbit around the sun, as well as the position of the moon in its orbit, we get to see how much light is casted onto the moon. So given when the moon is right here, we get to see when it's in a half phase. When it's close to the sun, it looks like it's practically dark, but we're still seeing the same side. So this is what causes the phases of the moon. In fact, if you want some fun experiments to do with your family and your kids, literally stick a ball on a stick and hold it around you and have it go into orbit, and you get to see the different phases of that moon. Or another fun experiment I always enjoy doing with some kids is moon phases, Oreos. It gives you an excuse to eat Oreos. And you get to create the different phases of the moon using Oreos. So one of the things I would sometimes do is encourage kids, go out, take a look at the moon. What phase do you see it in? Chomp off a little bit of the Oreo and create the phase of the moon. So here's a bit of the motions of the sky of how we see our phases of the moon, as well as how we see the different sunrises and sunsets. If there's a topic you would love for me to cover over, leave it down in the comments below. If there's a question you would love for me to answer, leave it down in the comments as well. Parents, if you're looking for a fun activity for your kids to do, futurereadysa.org has some fun activities that your kids can entertain themselves with, as well as get digital badges. So they're not only learning, but they are basically earning these awards to encourage them to keep learning. I recommend the Astronomy Plus mission because that's the one I have worked on. In fact, I'll leave a link in the description below for that one. So until next time, stay safe, stay healthy, and as always, never stop learning.